You think the future is ahead of you, don't you? Somewhere in front, waiting to unfold. But what if I told you that this simple idea is fundamentally flawed, that it reveals a deep misunderstanding about the nature of time itself? This is where physics gets strange, because according to our best theories, the future isn't ahead of anything. In fact, the very notion of ahead in time is an illusion, a convenient fiction we tell ourselves, but it doesn't hold up under the unforgiving lens of modern physics. So let's dissect this common assumption and see where it leads us astray. When you imagine the future as being in front of you, you're picturing time as a line, a series of moments laid out in sequence, with the past behind you and the future ahead. Seems intuitive, right? Well, it turns out that this picture is wrong, completely wrong. Here's the problem. This linear view of time is deeply rooted in classical physics, Newton's clockwork universe, where time ticks steadily onward. But the universe doesn't care about our intuition. It follows the laws of quantum mechanics and relativity. And in that world, time looks very different. In relativity, there's no universal now, no single moment that everyone can agree on. Instead, different observers slice up spacetime along different angles. Your now isn't the same as mine. Even the order of events can disagree, and in quantum mechanics, things get even stranger. The sharp lines between past, present, and future get hopelessly blurred. So the real problem isn't in the future. It's in our heads. We're dragging old, outdated notions from classical physics into a quantum world, treating time like a rigid ruler when it's really a fluid, shape-shifting entity. But this is just the beginning. The rabbit hole goes much deeper. And as we'll see, when you let go of the classical picture, a far richer and more unsettling reality emerges. One where time and information are inextricably tangled, where black holes redefine the possible. And the ultimate fate of the universe may hinge on the quantum nature of gravity itself. So buckle up, because we're about to take a journey to the edge of time, a place where intuition breaks down and imagination is your only guide. And what we find there will make you question everything you thought you knew. But this journey isn't for the faint of heart. We'll need to abandon comfortable assumptions, wrestle with paradoxes that twist the mind, and stare unflinchingly at the quantum heart of reality itself. Are you ready? Because once you see the world through Susskind's eyes, there's no turning back. You'll never look at time the same way again. Before we go any deeper, I need to ask you something. If you're here for comfort, this isn't the channel for you. But if you're here for truth, even when it's unsettling, take a second to support this mission. Hit like, subscribe, and leave a comment telling me what part of reality shocked you most. Every interaction tells the algorithm that depth matters more than distraction, and that thinking clearly still has value. If you want to keep tearing apart reality with me episode after episode, make sure you're following. We're just getting started. And that's just the first step. The real mystery is where this leads. But to get there, we'll need to dig deeper, to peel back the layers and confront the raw strangeness of a quantum universe. So if you're brave enough to question your assumptions about time, space, and reality itself, then join me. Hit that follow button, and let's plunge headfirst into the abyss. because what comes next will change the way you see everything, literally everything. And the only way out is through. So what is the future then? Well, buckle up, because the answer is going to make your head spin. In relativity, the future is a web, a tangled skein of possible paths, all woven together in the fabric of space-time. And here's the kicker. That web isn't fixed. It's dynamic, responsive, alive. It bends and warps and twists in response to everything that happens, every choice made, every action taken. Think about that for a second. The future isn't a static thing waiting for you to arrive. It's a living, breathing entity that you're constantly creating and reshaping with every passing moment. But it gets stranger, because when you zoom in to the quantum scale, that web starts to fray. The neat lines of classical causality start to blur and smear. The crisp distinction between before and after melts into a haze of uncertainty. In the quantum realm, the future is a ghost, a specter of possibility that haunts the present. It's not a single definite thing, but a superposition of potential outcomes, all coexisting in an eerie quantum limbo. And that's where things really start to get wild, because in a quantum universe, the future can influence the past. I know it sounds like science fiction, but it's real, and it's called retrocausality. And imagine two quantum particles entangled across time, one in the present, one in the future. Measuring the particle in the present instantly affects its future partner. But here's the mind-bending part. The future measurement can retroactively change the outcome of the present one. It's like the future is reaching back, tweaking the past to fit its own agenda. And if that doesn't make your brain hurt, consider this. In quantum mechanics, the future and the past can be indefinite, indeterminate. They can exist in a haze of potential, a fog of maybe. It's only when we measure, when we observe, that the fog condenses into something solid and real. So what does that mean for you? Sitting there in the present, trying to make sense of it all? Well, it means that the future isn't written. It's not some preordained destiny that you're helplessly hurtling towards. It's a dance, a duet between you and the universe, and every choice you make, every action you take is a step in that dance, shaping the contours of what's to come. But here's the thing. That dance isn't just about you. It's about everyone and everything, all tangled together in a vast pulsating web of cause and effect. A cosmic ballet where every dancer's moves reverberate across the stage, influencing every other in a dizzyingly complex pattern. And that web, that pattern, is what we call the future. But it's not a thing, not a place. It's a process, a becoming, a perpetual unfolding that we're all caught up in, whether we realize it or not. So the next time someone tells you that the future is ahead of you, just waiting for you to arrive, I smile politely and shake your head, because you'll know the truth, that the future is all around you in every quantum flutter, every relativistic twist, that you're not just hurtling towards it, but actively weaving it moment by moment, choice by choice. And that's the real magic. Not some mystical mumbo jumbo, but the raw, pulsating wonder of a universe that's far stranger and more malleable than we ever dared to imagine. But we're just getting started. Because to really understand the future, we need to grapple with the ultimate shapers of space-time itself, black holes. These cosmic monsters hold the key to some of the deepest mysteries of quantum gravity. And they just might rewrite the rules of time and causality as we know them. Black holes, the ultimate cosmic monsters, where gravity runs amok and space-time twists into a frenzy. These are the places where our understanding of time, causality, and the very nature of reality starts to unravel. But what does this have to do with the future? Everything, as it turns out, because black holes aren't just gravitational abysses, they're also quantum beasts, where the strange laws of the subatomic world collide with the extreme warping of space-time. And in that collision, something extraordinary happens. To understand it, we need to take a step back and look at black holes in a new way, not just as destructive voids, but as information processors, as cosmic computers that take in data and spit out answers, albeit in a highly scrambled form. This is the real magic of black holes. They don't just swallow information, they transform it. They take the intricate tapestry of cause and effect that we call the past and weave it into something new and strange, the future. But how? Well, it all comes down to a principle called the holographic principle. This is the mind-bending idea that all the information contained in a region of space can be described by a theory that lives on the boundary of that region. In other words, the 3D world we inhabit might just be a hologram, a projection of a 2D reality that lives on a distant surface. And black holes are the key to unlocking this holographic code. You see, when something falls into a black hole, its information doesn't just disappear. It gets smeared out on the event horizon, the black hole's boundary, like a cosmic graffiti artist. The black hole takes the intricate story of the unfailing object and spray paints it across the horizon in a chaotic, scrambled form. But here's the kicker. That scrambled information isn't lost. It's just encoded in a dizzyingly complex way. And with the right tools, you can reconstruct it, piece by painstaking piece. This is where the holographic principle comes in. The idea is that the scrambled information on the event horizon is a hologram, a lower dimensional projection of the higher dimensional reality that fell into the black hole. And by studying that hologram, you can learn about the original object in exquisite detail. But it gets even stranger, because the holographic principle doesn't just apply to black holes. It might be a fundamental feature of the universe itself. The idea is that our entire 3D reality could be a hologram projected from a 2D surface at the edge of the cosmos. And if that's true, then the future isn't just ahead of us in some vague, undefined sense. It's encoded in the boundary of space-time itself, waiting to be unscrambled and deciphered. Think about that for a second. The future, in all its infinite possibility, might be written in the cosmic code that surrounds us, a vast library of potential, waiting to be accessed by those who know how to read it. But reading that code isn't easy. It requires diving deep into the twisted heart of quantum gravity, where space and time lose their meaning and causality itself starts to break down. And that's where things get really mind-bending, because in the quantum realm, causality isn't a straight line. It's a tangled web where the lines between cause and effect blur into a hazy smear. In this quantum future, events don't just have one definite outcome. They exist in a superposition of possibilities, each one a ghostly echo of what could be. It's only when we observe, when we measure, that the quantum dice are cast and one future crystallizes out of the fog. But even then, the other futures don't disappear. They linger in the quantum shadows, affecting the present in subtle and spooky ways. It's like the future is a hall of mirrors, each one reflecting a different possible path, all of them real in some strange quantum sense. And here's the thing. We're not just passive observers in this quantum dance. We're active participants, shaping the future with every measurement we make, every interaction we have with the quantum world. In a very real sense, we're the ones casting the quantum dice, collapsing the wave function of possibility into the concrete reality of the present. And every time we do, we're steering the future down a particular path, pruning the infinite branches of what could be into the singular trunk of what is. But even that trunk isn't fixed, because in the quantum realm, the past is just as malleable as the future. Every measurement we make not only shapes what's to come, but also rewrites what came before. It's a dizzying concept, one that challenges our deepest intuitions about time and causality. But it's also a liberating one, because it means that the future isn't set in stone. It's a fluid, dynamic thing, constantly being reshaped by the choices we make in the present. And those choices matter. They matter more than we can possibly imagine. Because in a quantum universe, every action, every decision sends ripples cascading through the fabric of space-time, altering the course of events in ways both subtle and profound. So the next time you're faced with a choice, remember this. You're not just deciding for the present, you're casting a vote for one possible future over another. You're a co-author of the cosmic story, writing your chapter in the ever-unfolding saga of space-time. And that story is far from over. In fact, it's just beginning. Because, as we'll see in the final part of this series, the ultimate fate of the universe itself hangs in the quantum balance. Will it be a future of endless expansion, of heat, death, and decay? Or one of rebirth and renewal, a cyclic cosmos that's born anew in the fires of its own destruction? The answer, as always, lies in the quantum, in the strange and spooky world of entanglement, where the boundaries of space and time dissolve into a shimmering sea of possibility. The far future, a realm of speculation and wonder, where the familiar laws of physics unravel and the cosmos evolves in ways that defy imagination. This is the domain of the ultimate questions, the ones that probe the very fate of reality itself. Will the universe expand forever, its stars slowly fading into darkness as the fuel of creation runs dry? Or will it collapse back in on itself, space and time, reversing in a dizzying rush until everything is crushed into an infinitely dense point, a cosmic egg waiting to hatch a new universe? These are the questions that have haunted scientists and philosophers for generations. But as we've seen throughout this series, and the answers may lie not in the vast expanses of the cosmos, but in the tiny, turbulent world of the quantum. Because here's the thing. The fate of the universe isn't just a matter of gravity and geometry. It's a question of information and entropy, of the intricate dance between order and chaos that plays out on the subatomic stage. And at the heart of that dance lies a principle so strange and profound that it's almost impossible to wrap your mind around. A principle that could hold the key not just to the ultimate fate of the cosmos, but to the very nature of time itself. called the black hole information paradox. And it goes something like this. When something falls into a black hole, its information gets scrambled on the event horizon. But according to quantum mechanics, that information can never be lost. It's just transformed, encoded in the intricate dance of Hawking radiation that slowly evaporates the black hole over eons. But here's the paradox. As the black hole evaporates, it seems to take the information with it. It's like the black hole is a cosmic eraser, wiping clean the slate of the past and leaving nothing behind. And that's a problem. Because if information can be lost in a black hole, then the fundamental laws of quantum mechanics break down. The universe becomes unpredictable, chaotic, a place where cause and effect lose their meaning. So what's the solution? Well, it's a doozy. And it all comes down to the holographic principle we talked about in part 3. The idea is that the information that falls into a black hole isn't lost. It's just encoded on the event horizon in a vastly complex and scrambled form. And as the black hole evaporates, that information is slowly released back into the universe, albeit in a form so chaotic and random that it's almost impossible to decipher. But here's the kicker. If the holographic principle is true, then this scrambling and unscrambling of information isn't just a property of black holes. It's a fundamental feature of the universe itself. In other words, the cosmos is a vast information processor, taking in the data of the past and spitting out the complexity of the future. And the ultimate fate of that cosmos depends on how efficiently it can process that information. If the universe is a perfect information processor, then it can keep going forever, endlessly computing its way into an ever-expanding future. But if it's an imperfect processor, if information gets lost or corrupted along the way, then the future becomes uncertain, a haze of possibilities that never quite resolves into clarity. And that's where things get really mind-bending, because according to some theories, the efficiency of the cosmic information processor depends on the very geometry of space-time itself. In a flat universe, one that expands forever, information has room to spread out and dissipate. But in a curved universe, one that collapses back in on itself, information gets concentrated and compressed, making the cosmic computation more efficient. So the fate of the universe, the ultimate future that awaits us all, could hinge on the shape of space itself, on whether the cosmos is flat or curved, open or closed. But even that might not be the end of the story, because there's another possibility, one that's even stranger and more mind-bending than anything we've talked about so far. It's called the cyclic universe theory. And it goes something like this. Imagine a universe that's curved but not quite closed. A universe that expands and contracts in an endless cycle, each iteration a little different from the last. In this cyclic cosmos, the future is always born from the ashes of the past. Each contraction is a cosmic reset, a chance for the universe to reinvent itself anew. And each expansion is a new chapter in an endless story, a fresh canvas upon which the intricate patterns of reality can unfold. But here's the thing. In a cyclic universe, the arrow of time itself becomes a loop. The future becomes, the past becomes the future, in an endless cycle of rebirth and renewal. And that means that the ultimate fate of the cosmos isn't a destination, but a journey. It's a never-ending odyssey through the infinite possibilities of the quantum multiverse. In this view, we're not just passive observers of the future, but active participants in its creation. Every choice we make, every action we take, ripples out across the fabric of space-time, shaping the contours of the cosmos in ways both subtle and profound. And that's the real message of this series, that the future isn't something that happens to us, but something that we make. That we're all co-creators of the cosmic story, weaving the tapestry of reality with every quantum thread we spin. So the next time someone tells you that the future's written, that your fate is sealed, remember this. In a quantum universe, nothing is certain. The future is an open book, a story waiting to be told. And you're the storyteller. You're the one holding the pen, the one with the power to shape the narrative of your own existence. So use that power wisely. Choose your actions with care, knowing that each one echoes across the aeons. And never forget that in the grand unfolding saga of the cosmos, you're both author and protagonist, hero and historian. The future is yours to write, so make it a story worth telling. And with that, our journey comes to an end. But the real adventure, that's just beginning. So keep asking the big questions. Keep probing the depths of reality. Keep pushing the boundaries of what's possible. Because in a universe as vast and mysterious as ours, there's always more to discover, always new frontiers to explore. And who knows, maybe, just maybe, the key to unlocking the ultimate secrets of existence lies not in some distant galaxy or far-flung future, but in the quiet, curious corners of your own mind. So keep thinking, keep dreaming, keep reaching for the stars, because in a quantum universe, anything is possible. And that, my friend, is the real magic of the cosmos. If you made it this far, you're part of the rare few who refuse easy answers and actually want the truth. If you want to keep dismantling reality with me and exploring the deeper structure behind everything we think we understand, make sure you're subscribed. Leave a comment with the question that's still bothering you, and let's keep pushing into the silence together.